Hello students, welcome to another live class of Aptdemy. Now we'll be considering a problem on physics. Based on your feedback, I have picked up this problem for discussion in this live class. So before we proceed, just let me tell you that Aptdemy is arranging a demo class for the students who are interested to join Aptdemy. For them, there will be a live class on successive Sundays. Next Sunday at 9:30 in our Lake Town branch, there will be live class from 9:30, demo class from 9:30 to 5:30, and all the three subjects, physics, chemistry, maths, will be covered. Some topics, selected topics, will be covered by the academic faculty members. And if you are interested, you can join us. You just go to our website and portal, and there are certain email addresses, phone numbers, where you can contact. You can intimate your willingness, and you can join us on next Sunday, that is 18th June at 9:30 a.m. in our Lake Town branch of Aptdemy. Okay, if you are interested, please write to us. Okay, now let us consider a problem related to RC circuits in electricity, physics problem. So this is the problem statement. You see what is the problem? This problem also appeared in a recent IIT advanced exam. So it is like this. Okay. In a circuit shown, in a circuit shown in figure, the switch S, this is a switch. Switch is connected to position P for a long time so that the charge on the capacitor becomes Q1 microfarad. So this is a capacitor sort of thing, parallel plate capacitor or whatever. This is a capacitor, symbol of capacitor. So this is one capacitor. So that the charge on the capacitor becomes Q1. Then the switch is switched to, S is switched to position Q. After a long time, the charge on the capacitor is Q2 microcoulomb. Find the magnitudes of Q1 and Q2. That is the problem. So initially, just let us redraw the circuit. So this is one resistance, which is 1 ohm. This is another resistance, it is 2 ohm. This is a 2-volt battery. And there is a capacitor whose value is 1 microfarad. And there is another battery here, which is 1 volt. And now see, here when the switch was in position P, the circuit looks like this because it has no significance. This line, this wire, is disconnected to the circuit. So there is no significance of this circuit as such. As far as electrical current flow is concerned, this conductor has no significance. Moreover, in the steady state, this capacitor behaves like open circuit because these are DC batteries. So these are supplying voltage which are not function of time. So if a DC voltage, if a DC voltage is applied across capacitor, the capacitor does not contact. It works like a brake. The condenser works like a brake, open circuit. So what happens as far as electrical current flow is concerned, this capacitor has no significance. So I can equivalently write this circuit, redraw this circuit like this. This is 1 ohm, this is 2 ohm, and two batteries. So it does not matter whether the capacitor is there or not. So this is the equivalent. Now, I just advise you, just always in such type of problems, mark some points on that circuit. So call this point 1, call this point 2, call this point 3, and call this point 4. Okay. So you can say that negative pole of the battery, this battery, which is 1 volt battery, is connected to 0.4. Positive negative pole of this 2 volt battery is connected to 0.4, and all these points are at same potential. You can assume like this because they are connected. Now what happens in this circuit? There is no, though there is a capacitor between 0.2 and 4, but it has no role as such in respect of electric current flow. Now, in this circuit, since it is a 2 volt battery, here it is 1 volt battery, so net voltage will drive a current in the anti-clockwise direction. This much you know, because this is higher voltage battery, this is lower voltage battery. So this will drive more current than this, and the net current flow will be in this direction, anti-clockwise direction, and I write this current as I. Okay, so what is I? Using Ohm's law, I can write 2I plus 1I is equal to 2 minus 1. So this is Ohm's law. 2 into I plus 1 into I equal to 2 volt minus 1 volt. So it is 3I equal to 1. So I becomes 1/3 amps, 1/3 ampere. So in this circuit, the current flows I is equal to 1/3 of an ampere. Is it okay? Now what happens? I have taken this point again. I am taking this point. I have taken as 0.1. This point has taken as 0.2. This point we have taken as 0.3, and this point I have taken as 0.4. And 0.4 is a common point of capacitors. This pole, this battery is negative charge pole. This battery is negative pole. These are all common points. They are all short circuited, you can say. Now what happens? Now we apply Ohm's law and write the equations for potentials at points 1, 2, 3, and 4. So if I write potential of point 1 is V1, potential of point 2 as V2, potential of point 3 as V3, potential of point 4 as V4, then what are the relations we have? Then what happens? View current is flowing in this direction, anti-clockwise direction, because these batteries have. So what happens? V1 minus V2 is how much? V equal to IR. Simply Ohm's law, if I apply this, 2 times I. 2 times I means I have already found 1/3, so it is 2/3. So V1 minus V2 is 2/3. Let me write. V1 minus V2 is 2/3. 2/3 of a volt. V2 minus V3, again Ohm's law, it is 1 into I. So it is 1/3. So V2 minus V3 is 1/3. Okay, and V3 minus V4. V3 is connected to the positive pole of this battery, and V4 is this much. So V3 minus V4 is definitely 1 volt. So V3 minus V4 is 1 volt. And V1 minus V4 is also 2 volt, because V1 and V4 these are connected. V1 is the potential of positive terminal of this 2 volt battery, and V4 is the potential of negative terminal of 2 volt of this 2 volt battery. So V1 minus V4 is 2 volt. So what is V2 minus V4? So if I add these two equations, so V2 minus V4 becomes how much? V2 minus V4 is 1 plus 1/3. This is 4/3. So V2 minus V4 is 4/3. Now, what happens? V2 minus V4 is 430. But V2 minus V4 is the potential difference across the plates of the terminals of the capacitor. Is it not? So Q equal to CV, if you write, so Q1, which is the charge accumulated by this condenser in the steady state. That means when the switch AC is kept in position P, when it is connected like this, P is disconnected, then the steady voltage in the steady state, when there is no transient, then capacitor's voltage will be V2 minus V4 and multiplied by C. So Q1, which is the charge on the capacitor, Q1 is actually C into V2 minus V4. V2 minus V4. And C is 1 microfarad. So it is 1 microfarad. And V2 minus V4 we have calculated, it is 430 volt. So it is how much? 430 microcoulomb. So 430 microcoulomb is 1.33 microcoulomb. So the Q1, value of Q1 is 1.33 microcoulomb. Okay. So Q1's value is 1.33 microcoulomb. Okay. So this is the thing. First part is answered. Now what happens? Now switch is moved to position Q, and then it is kept for a long time, and after a long time, what is the charge acquired by the capacitor? That is to be found out. Now here, how do I do? Same thing, but you have to redraw the circuit in the present configuration. That means switch is kept in position Q. So the circuit, the battery, 1 volt battery is not coming into picture as far as electrical circuit is concerned. Let us redraw the circuit. In this case, what happens? So now what happens? This is disconnected and it is connected to, AC is connected to position Q. So this battery is bypassed basically. And now after long time, actually what happens? The charge of this condenser becomes Q2. So it is Q2. Okay. Now how the circuit looks like? Now the circuit looks like what? Simple. There is only one battery because this battery is bypassed. This is a 2 volt battery, and sorry. Now this is a 2 volt battery. This is 1 ohm resistor. This is 2 ohm resistor, and this is the 1 microfarad capacitor. Now in this situation, again in the steady state, as far as electrical current is concerned, this 1 microfarad is working as an open circuit. So as far as electric current is concerned, I can write the circuit looks like this. 2 volt battery, and it is like this. So in between there is a capacitor. So its presence or absence does not matter as far as electric current flow is concerned. So current will flow again in anti-clockwise direction. Let the current be I. So current I multiplied by 1 plus 2 by Ohm's law. 2 plus 1 multiplied by I is equal to 2 volt. So I is actually 2/3 ampere. 2/3 of an ampere. Okay, now in this situation, when I is 2/3 ampere, now let us redraw the circuit again. Capacitor is here. Call this point 1, call this point 2, call this point 3, and this point, this is also 3 because there is no resistance in between. So this point is also 3. So these all are common actually. The other pole of the condenser, other plate of the condenser, and the negative pole of the battery, and this point, these are all common points. So we have calculated, it is like this. So we have calculated to be 2/3 of an ampere. So if I write V1, V2 and V3 are the potentials of these points. So this is V1, this is V2, this is V3. So V1 minus V2 is, this is 2 ohm resistance and this is 1 ohm resistance. So 2 multiplied by R, that is 4 by 3. Okay, this is 2 ohm resistance. And V2 minus V3 is how much? V2 minus V3 is 1 into I, so it is 2/3. But V2 minus V3 is the potential across the condenser also, because now this point and this point are same. Okay, this is point 1, this is point 2, this is point 3, and this is also point 3 because electrical potential, this is entire thing is short circuited, zero resistance you can say. So voltage across the capacitor, voltage is V2 minus V3. So V2 minus V3 multiplied by C should be equal to Q2. So Q2 is, C is 1 microfarad and V2 minus V3 you have calculated. V2 minus V3 is 2/3 into 2/3 volt. So it is 2/3 microcoulomb. 2/3 microcoulomb is actually 0.6666 microcoulomb. So I can write it 0.67 microcoulomb approximately. So Q2's value is 0.67 microcoulomb. So Q2 is 0.67 microcoulomb. Q2 is 0.67 microcoulomb. And Q1 is 1.33 microcoulomb. Okay, so these are the magnitudes of Q1 and Q2. I think the problem is clear. Very interesting problem, but straightforward. Okay, so you have, if your basics are clear, you can easily calculate, easily solve this problem. Okay, thank you very much. I hope you have understood the concept behind this problem. Try to solve our worksheets, solve the problems, and gain confidence on the subject. I hope you will be doing well in the exams. Thank you very much.